Hi dear, so welcome back to a new video. In today's video, we are going to see solvation and association. What is solvation and what is association? What is in relationship with the solubility? That we will see today, okay? So this, keep it in your mind. It is 2-mark question, okay? Either it will come define solvation and in the case of association, define it. Otherwise, if it is coming in the 5-mark section, means it will come like differentiate between solvation and association. Okay, so now we'll see the solvation, how it is affecting the solubility and what is solvation. So solvation is the interaction between solute particles and solvent molecules. So you can remember solute is going and hugging the solvent. Okay, so if the solute and solvent is hugging, the solvation is taking place in the simple. It's a love between the solute and solvent. Okay, so when a solute dissolves, the solvent molecules will surround it and stabilize it. Okay, so thereby it will increases the solubility. So in the case of solvation, it increases the solubility. Okay, so if the solvent is water, the solvation we will call as hydration. Okay, so if the solvent is water, the solvation will called as hydration. So for example, we are taking the sodium chloride, NaCl. Okay, that we are going to dissolve in the water. So water molecules surround as Na plus and Cl minus ions. So hydration of shells, the ions become stable and NaCl will start dissolving. So NaCl in water is an example of solvation, and glucose in water is an example of solvation, and iodine in hexane is an example of solvation. What are the examples? NaCl in water, glucose in water, and hexane in iodine in hexane. Okay, so keep it in mind, solvation is common in polar solutes. Okay, polar solutes will dissolve in polar solvent. Okay, so it is, we can tell the solvation is the molecular level process. What? It is a molecular level process and it involves the intermolecular forces like hydrogen bonding, and we know the hydrogen bonding is the strongest bond, right? And we have the dipole interactions and van der Waals forces. These are the intermolecular forces involved in the solvation. So what is solvation? It is the interaction between solute and solvent, we will call it as solvation. Okay, so keep it once again, when a solute dissolves, the solvent molecules surround it. Okay, when solute is dissolving, okay, we have the beaker, we have the solvent here, and we are adding the solute. Okay, so when a solute is getting dissolved, the solvent molecule will surround the solute and it will make it stabilize. Okay, that is what we know, it is solvates it will form, right? So the process we will call it as solvation. In that case, when the solvation is taking place, the solubility will increases. So I hope you understood the solvation. Now we will go for the association case. Okay, so in the association, when a solute molecules or ions combine with each other in a solution, they form a bigger units, reducing the number of free particles. So we can see solute will be like this, right, in the solution. Okay, so this solute, what it will do, it will attract each other and it will form a one unit. That unit will be bigger. Okay, so it will reducing the number of free particles. So this distance is there, no? It will go near and it will attach. Thereby it will reduce the number of free particles. Okay, so thereby it will take time to break, right? So thereby your solubility may decreases in the case of association. So here the solubility will decreases. So why association happens? How? So we can see because the molecules are ions, try to become more stable by attracting each other. That's the mechanism happening in the association. What? Molecules or ions will try to become more stable by attracting each other. So this association is common in non-polar solvents. By why? Because inverse solvation is weak in the case of non-polar solvents. So here we can give the example of benzoic acid molecules join to form the dimers. Okay, so in that case decreases the particle number and abnormal weight, molecular weight will increases. That will lead to decreasing the solubility. Okay, and other example we can tell fatty acids in organic solvents, like we can tell it will form the aggregates. Okay, aggregates like micellar, like clumps it will form. So we know if the clumps is formed, it is very difficult to break it. So gradually the solubility will decreases. This is what the difference between the solvation and association. The thing which you have to remember in the solvation and association is, solvation is the interaction between solute and solvent, but association is the interaction between solute and solute. In the case of solvation, it will increases the solubility, and in the case of association, it will decreases the solubility. In the case of solvation, we can tell it is for polar solute, it is especially for the polar compounds, and association is for non-polar compounds. And example you can give sodium chloride in water, glucose in water, iodine in hexane. Okay, in the case of association, you can give the examples like benzoic acid. Benzoic acid will form the dimer, and fatty acids in the organic solvents. Okay, these are the example, and this is what solvation and association. I hope you people understood. Okay, so we will see in the next video. So till that time, bye bye.